So brute force is applicable to a wide variety of problems. So as I said, example problems. So we can apply it for the wide variety of problems. Then scan the array to find the smallest element in the unsorted portion. Bubble sort algorithm is the simplest sorting algorithm that runs through the list repeatedly. So what are the advantages? It is simple to understand and implement. No extra memory is needed. Hello everyone. Welcome to the session of Unit 3 of the subject Design and Analysis of Algorithm. This is Chandana C, Faculty of BCA, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. So today I am going to discuss the topic of brute force and exhaustive search. This is in the Unit 3. So today I am going to just discuss regarding the brute force. Come, let us have a look into the agenda. Today I am going to discuss regarding the brute force method. In agenda, it is going to cover introduction to brute force, then selection sort, bubble sort and sequential search. So these are some of the problems we are going to discuss under the brute force approach. Firstly, we move on to the topic brute force. Let us learn what is brute force. So it is a straightforward approach for solving a problem. It tries all possible solutions. So whatever the solutions are required, it tries all the solutions to find correct one. And it does not use any shortcut strategies. It checks everything until the answer is found. So in an array, if I want to find a key element, it searches for the key element present in an array. Here we have some of the examples. Using the brute force, we can find. So which are those? Computing a power n. So if the n value is 5, I need to compute a power n. What is that? A power 5, which means a into a into a into a. So I am computing a power 5. So this also we can compute. N is a positive integer and a should be greater than 0. Next, searching for a given value n in a list. So which means I need to search a key value in a list. Then computing n factorial. That is 5 factorial means 5 into 4 into 3 into 2 into 1. So like this. Then multiplying two matrices. So these are some of the examples where brute force approach is applied. Next we come to know what are the advantages of brute force. So brute force is applicable to a wide variety of problems. So as I said, example problems. So we can apply it for the wide variety of problems. It is very useful for solving small size instances of a problem. Then even though if the problem statements are inefficient or parameters are inefficient, even though we can solve the problems where the input size is small. So like sorting, searching and string matching. Next we will look into the when to use this brute force. When to use? When we have an input size small. Next, when it is hard to find smarter algorithm. When we need quick and correct solution. So in these situations, we can use brute force method to get the solution. The time complexity of the brute force algorithm depends on the size of the input. So if the input size increases, the execution time also increases. So depend on that, we will finalize the time complexity, that is big O of n or big O of n square. Next, we will move on to the selection sort. So this is one of the sorting method used under the brute force. So in the selection sort, it is a simple comparison based sorting algorithm. How it is going to work? It works repeatedly. Why it works repeatedly? For finding the minimum or maximum element from the unsorted part of the array, and it is moving it to the beginning. So it searches for the minimum element and maximum element. If it finds, it moves that element to the first element towards the sorted array. How it works? Let us have a look into how the selection sort works. Firstly, start from the first element, then scan the array to find the smallest element in the unsorted portion. Okay. Next, if found, what we should do? Swap it with the first element. Then starting with the second element, scan the elements to the right to it, find the smallest among them and swap it with the second element. So like this, the process repeats until the array is sorted in ascending or descending order. Next, here I have a simple example. So I have 4 elements in an array, so which are unsorted. In the step 1, I have taken all the 4 elements of an array. Now 7 is the first element. I am considering as a current element. Now these 3 elements are in the unsorted part. In these 3 elements, I will look into the minimum element. I am going to find out which is the minimum element. So here I will check 5 is greater than 4 or not. Yes, 5 is greater. Next comes I will be incremented. Next is compares with the 4 and 2. In 4 and 2, 2 is the minimum element. As I got the 2 as a minimum element, then swap it with the current element. If the current element is larger than the minimum element, then swap it. Here I brought 2 in the first element. It is sorted now. It is sorted. Next, the I will be incremented. Next, it is a current element. So it checks with the 4 and 5. Yes, 4 is the minimum element. It swaps. 4 comes in the place of 5 and 5 goes to the place of 4. Next, now I have in a 5 and 7. Next, in the sorted list, I have 2 and 4. Now, 5 is the current element. It checks with the 7. Yes, 5 is a minimum. It is 5 is lesser than 7. So, no swapping is done. The 5 comes to the sorted part. Here, I have 3 elements in a sorted part. 7 remains in the unsorted part. Now, 7 is the current element. Then, no other elements are present in the list to check. So, 7 also comes to the sorted part. So, this is how selection sort works. So, let us have a look into the algorithm of the selection sort. So, here algorithm is a keyword I am using. Selection sort is the name of the algorithm. Here I am giving the parameters array from 0 to n minus 1. What I am going to do is a sort a given array by selection sort. Here I am entering the input a array of 0 to n minus 1 for orderable elements. So, what output I am getting? It is the array elements is sorted in ascending order. So, initially I am assigning I to 0 to n minus 1. What I should do? So, I am in the array. For example, I have 7, 4, 2, 5 means I have a 4 elements 7, 4, 2, 5. The array index of 7 is 0, 4 is 1, 2 and 3. So, here I have 4 elements, that is n is equal to 4. So, the array index is showing 3, that is n minus 1. So, I need to sort from I is equal to 0 to n minus 1. So, that thing I am telling here. Next, I am assigning the I value where it is in the 0. So, this is how what I call is a minimum value now. Next, for j is equal to I plus 1 to n minus 1. So, I am telling j is equal to I plus 1. So, what is I plus 1? That is 0 plus 1. that is j is equal to 1. Now j value is in the 4th place. I need to do this also till n minus 1. So if a of j is less than a of min, so check a of j is less than a of min, yes, then it sorts. The 4 comes here and 7 swaps. See, a of I and a of min, swap that. So this process goes on till the given array is sorted, that is 7, 4, 2, 5 is sorted. What I will get the answer after sorting? 2, 4, 5, 7. So this is my answer. So this is how the algorithm of the selection sort works. So what are the basic operation we used? We used comparison, isn't it? We used comparison, that is lesser than. We use lesser than comparison operator here. Then what will be the space efficiency? So it is big O of 1 as the n numbers we have given. Then the time efficiency will be big O of n square, because the number of operation grows gradually with the size of the array. So as my array input size increases, the time complexity will also increases. We will move on to the bubble sort. This is also one of the sorting method we are going to perform using the brute force method. Bubble sort algorithm is the simplest sorting algorithm that runs through the list repeatedly, compares adjacent elements and swaps them if they are in wrong order. So this process is repeated until the list is sorted in increasing or decreasing order. So how it is going to work? Starts from the beginning of the array. Yes, we need to start from the beginning. Next, compare the first elements. Swap them if first element is greater than the second element. Move to the next pair and repeat. After each full pass, largest element bubbles to the end of an array. Okay, this is how the bubble sort works. Let us have a look into the algorithm, how it is going to work. So, if I have an array, for example, if I have an array, for I is equal to 1 to n minus 1, from first element to last we need to do. Then for j is equal to 0 to n minus I minus 2. If a of j is greater than a of j plus 1, then we need to swap that a of j and a of j plus 1. See how n minus I is equal to now 1 I am telling. So firstly we need to take first two numbers. We need to compare these two. Okay, that is for j is equal to 0 to n minus I minus 2. So we need to compare these two. If a of j is greater than a of j plus 1, is a of j is 0 now. So what is the j value? J value is 0. If a of j, that is the value 9, is greater than a of j plus 1. If it is greater than a of j plus 1, this is j plus 1. The 2 is in the place of j plus 1. Yes, 9 is greater than 2. Then swap these two. 2, 9, 5, 7. Then again compare these two. J will be incremented to, compare these two. J will be incremented to 1. Then compare 9 with 5. 9 is greater than 5. Then again swap these two. Answer is 2, 5, 9, 7. So like this, the algorithm of the bubble sort works. So this is how the bubble sort algorithm works. Now we look into the advantages and disadvantages of the bubble sort. So what are the advantages? It is simple to understand and implement. No extra memory is needed. How much input we have given into the array, and that only it searches within the adjacent numbers whether it is greater or lesser, and it is going to swap within the array. So extra memory is not required in the bubble sort. What are the disadvantages we come across? It is very inefficient for large lists. So we can't use this bubble sort for the complex programs. Not suitable for performance, the critical task. The performance is not that much good for the critical, that is complex programs. The process of traversing the list is repeated until the list is sorted, then the time complexity will be big O of n square. This is how the bubble sort works, and we come across the advantages and disadvantages of the bubble sort. Here I have a simple example to solve using a bubble sort. Here I have a list of 5 elements 2, 7, 9, 3, 4. So iteration 1. What I am doing here in the iteration 1? So I am comparing these two 2 and 7. 2 is lesser than 7. So no swap. My array will be like this 2, 7, 9, 3, 4. Next, in the step 2, I will compare other 2. I will compare next set of elements. I will compare next set of elements, that is 7 and 9. 7 is lesser than 9. So no swap. Hence my array list will be like this 2, 7, 9, 3, 4. Next, I am going to compare with these two elements 9 and 3. 9 is lesser than 3? No, 9 is greater than 3. Hence, 3 should swap with 9 and 9 should swap with 3. So, my sorted array element will be 2, 7, 3, 9, 4. So, next I am going to compare with 9 and 4. So, 9 is greater than 4. Hence, do swap. Here also I did swap. So, after swapping 9 and 4, so what is the answer? 2, 7, 3, 4, 9. So, this is the outcome of the first iteration. This is the outcome of the first iteration 1. So, now I have a array list 2, 7, 3, 4, 9. So, now I am performing the second iteration. Now, I am performing the second iteration. Again from step 1. So, consider these two. Consider the first two elements 2 and 7. 2 is lesser than 7. So, no swapping. No swap. Again compare 7 and 3. Yes, 7 is greater than 3. So, swap. Then I will get 2, 3, 7, 4, 9. Next compare 7 and 4. Yes, 7 is greater than 4. Now do swap. 2, 3, 4, 7, 9. Next I have 7 and 9. 7 is lesser than 9. So, no swapping. Hence, the output of the iteration 2 will be 2, 3, 4, 7, 9. So, this is the sorted. Here, the elements are sorted using the bubble sort. This is how the bubble sort works to sort the elements in an increasing order. Let us now move into the sequential search. So, what do you mean by search? To search for something, isn't it? So, we will have something in your mind. If I have to search for a pencil, I will be keep on searching in my room or cupboard, isn't it? So, like that, here we are going to search one key element which is present or not in a given array. So, here we are going to search for a key element in a given array, whether it is present or not. It is also known as linear search. The sequential search is also known as linear search. So, this algorithms finds a given element, that is key, in a list of elements with big O of n time. So, how much it is taking? Big O of n time complexity when n is the total number of elements in the list. So, how it is going to work? This search process starts comparing of search element with the first element in the list. So, what is the key element we have given? It goes on, compares with the key element with the elements present in an array. If both are matching, then result with the element found. Otherwise, search element is compared with the next element in the list. If the key element is found in a 0 index of an array, then it gives the output as element found in index 0. If it is not, it keeps on searching with the next element. If both are matched, then the result is element found. If the element present in the second element, then it displays the result element found. Otherwise, it repeats the same with the next element in the list until search element is compared with the last element in the list. If the key element is not present anywhere in the list, then it gives element not found in the list. Hence, it gives the output element is not present in the list. If that last element also doesn't match, then the result element not found in the list. That means the search element is compared with the element by element in the list. So, in the searching algorithms, so each and every element is compared with the key element to search where the key element is present in a given array. Next, we will move on to the algorithm of sequential search. So, algorithm, here I have written a keyword algorithm, the problem name, and I have given a parameters array and key. I have entered the two parameters array and key because I need to search the key in the array, whether it is present or not. Now, I am assigning array of n to k. So, I don't know where the key element is present in an array. I am initializing key to the array elements. Now, I am assigning I is equal to 0. From 0 to n minus 1, I need to search. While a of I is not equal to k, if the first element of an array a of 0 is not equal to key, then what I should do? Then increment the I plus plus or I plus 1, increment the I. If a of I is equal to k, that is, I have incremented the I value, now I value will be 1. So, whichever the element present in a index A of 1, that is, if it is equal to given element key, then it displays the element found, found, else return minus 1. It returns minus 1. Next, we will move on to the simple example. Let us know how the sequential algorithm works. Here I have a example of an array 5, 4, 3, 2, 1 and my key is 3. I need to search the key element 3. So, I have a n is equal to 5, n numbers. So, index is 0, 1, 2, 3, 4, that is n minus 1, that is 4 index value. Start from the index 0. As we have in the algorithm, I is equal to 0. Initially, we have I is equal to 0, isn't it? So, from 0 index, we are going to start searching. I have first element is 5 in a given array and I need to search the key. What is the key value? 3. Then compare. 5 is equal to 3? No, 5 is not equal to 3. Then I plus plus. Then I becomes 1. It checks 4 is equal to 3? No, 4 is not equal to 3. Then again I plus plus. Now I value is 2. What is there in the 2? Index 2. What is there in the index 2? We have 3. 3 is equal to 3? Yes. I got the key element in the index of 2. This is how the sequential search works. So, we found the key element 3 in an index 2. So, today I discussed regarding the brute force method. So, under the brute force, we studied selection sort, bubble sort and a sequential search. So, in the next session, I am going to discuss regarding the exhaustive search. So, which contains the searching methods. They are traveling salesman problem, knapsack problem and also the depth first search and breadth first search. So, these are the topic I am going to discuss in the next session. Thank you.